Arithmetic progression. In this chapter, we'll see what is an arithmetic progression and the terms related to arithmetic progression. Patterns in nature. You see patterns all around you in nature. Take for example this beehive. Now let us look for some patterns which occur in our day-to-day life. Example 1. Shakila put rupees 100 into her daughter's money box when she was 1 year old and increased the amount by rupees 50 every year. The amounts of money in rupees in the box on the first, second, third, fourth and so on birthdays were rupees 100, rupees 150, rupees 200, rupees 250 and so on. Second example. Reena applied for a job and got selected. She has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of rupees 500 in her salary. Her salary for the first, second, third and so on years will be 8,000, 8,500, 9,000 and so on. In the above two examples, we see that the succeeding terms are obtained by adding a fixed number to its preceding term. This type of series is called an arithmetic progression. Let us look at arithmetic progression in detail now. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Let us look at this example. 10, 20, 30, 40 and so on. 10 is the first term of this AP here and we get the next terms by adding 10 to every preceding term. This fixed number is called the common difference of the AP. For this AP, the fixed term or the fixed number is 10. Similarly, let us look at this series which is decreasing in order 12, 10, 8, 6 and so on. 12 is the first term of this AP. Minus 2 is the common difference. Every succeeding term obtained is by adding minus 2. The common difference is negative here. So any arithmetic progression can be written down as A plus D, A plus 2D, A plus 3D and so on, where A is the first term of the AP and D is the common difference. This is called the general form of an AP, which is represented by this box, that is A plus D, A plus 2D and so on. Notice that if first term is A1, second term is A2 and the third term is A3 and the nth term is AN, then A2 minus A1 is equal to A3 minus A2, so on is equal to AN minus AN minus 1. That is, the difference of the term and the term preceding it is equal to the common difference D. This means that if we know the terms of an AP, we can find the first term and the common difference. Also, if we know the first term and the common difference, we can find all the terms of an AP. Now look at the two progressions carefully. The first one is 10, 20, 30, 40 up to 100 and the second one is 10, 20, 30, 40 and so on. What difference do you find here? The first term is same and even the common difference is same. Now in the first one, that is on the left side, number of terms in this series is finite and hence they are called finite arithmetic progression. And the series on the right, the number of terms in this series is not finite and hence they are called infinite arithmetic progression. Can you guess the 7th term of this AP? For this series, it is quite simple to say that 7th term is 70. But what about the 7th term of this series? 13, 21, 29 and so on. The following algorithm suggests how to determine whether a sequence is an AP or not when we are given an algebraic formula for the general term of the sequence. Let's look at this algorithm. Step 1. To obtain an, that is nth term of the AP. Step 2 is to replace n by n plus 1 to get n plus 1th term of the AP, that is a n plus 1. Step 3 is to calculate an plus 1 minus an. Step 4 is to check the value of an plus 1 minus an. If an plus 1 minus an is independent of n, then the given sequence is an AP. Otherwise, it is not an AP. Let us check how to detect whether a given sequence is an AP or not. We need to find if the sequence defined by an is equal to 4n plus 5 is an arithmetic progression or not. Along with that, we need to find the common difference of the progression. We have an is equal to 4n plus 5. Replacing n by n plus 1, we get an plus 1 is equal to 4 times n plus 1 plus 5. That is equal to 4n plus 9. Let us now take the difference. So an plus 1 minus an is equal to 4n plus 9 minus 4n plus 5. That gives you 4. Now 4 is independent of n. So the given sequence is an arithmetic progression with common difference of 4. Now let's find out if the sequence defined by an is equal to 2n square plus 1 is an AP or not. First of all, we have an is equal to 2n square plus 1. Let's now replace n by n plus 1 in an. Replacing it, we get n plus 1 is equal to 2 times n plus 1 whole square plus 1. Upon expansion, it gives 2n square plus 4n plus 3. Let's take the difference of an plus 1 and an. So we get an plus 1 minus an is equal to 2n square plus 4n plus 3 minus 2n square plus 1. That gives you 4n plus 2. Clearly 4n plus 2 is not independent of n and therefore not constant. So this sequence cannot be an arithmetic progression. Here is a box of candies. A kid picks up 1 candy at the first time, 4 candies in the second time, 7 candies in the third time, and so on. If we notice 1, 4, 7, etc., the number of candies is increasing by 3. So if I ask you how many candies the kid picks up in the 6th time, how will you answer that? Yes, it is easy. Third time the kid picks up 7 candies and we have seen that the number of candies is increasing by 3. So in the 4th time the kid will pick up 7 plus 3 candies, that is 10 candies. Similarly, in the 5th pick he will have 10 plus 3, that is 13 candies. And finally in the 6th pick he will have 13 plus 3, that is 16 candies. This was easy to get, but now if I ask you how many candies did he pick up at the 30th time, how will you find out? The above process would be a little tedious. Now if we study the number of candies picked, we'll find that there is a sequence or a pattern between them. 1, 4, 7, 10, 13, 16 and so on is an arithmetic progression with a common difference of 3 and the first term being 1. So here comes the formula to it. There is the list of the number of candies the kid had picked up. 1, 4, 7, 10, 13, 16 and so on. Clearly this is an arithmetic progression. Now the formula I'll give you will help you find out the nth term of any AP. That is, if you know that you have an AP and you want to find, let's say, the 30th term of it, you can do so. The formula is given by an is equal to a plus n minus 1 times d, where a is the first term of the AP, an is the nth term of an AP, and d is the common difference. Let's say we have to find out A30, that is the 30th term of this AP. How will you find out? Over here, the first term, that is A, is equal to 1, n is equal to 30, and the common difference d is equal to 4 minus 1, that is 3. Let's put the entire thing in the given formula. So we get A30 is equal to 1 plus 30 minus 1 times 3, or A30 is equal to 88. Therefore, the kid picked up 88 candies in the 30th time. Now what if the last term of the AP is given to you and you have to find out the nth term from the end? Here is the formula for that. Nth term of an AP from the end is given by L minus n minus 1 times d, where L is the last term, n is the number of terms, and d is the common difference. Let us take a quick example. Let's say that last term of an AP is 100 and the common difference given is 1 by 3. Let's say you have to find out the 16th term from the end. So n16 would be equal to 100 minus 16 minus 1 times 1 by 3, or 100 minus 5, that is equal to 95. So 16 term in this AP from the end would be 95. Let us now look at this question from the nth term of an AP. On a building construction site, a truck delivers 20 bags of cement on first day of the month, 23 bags on the second day, and so on, increases the number of bags by 3 every day. What is the number of bags that it delivers on the 23rd day of the month? Let's try to find out. Here you can see that the number of bags delivered on the first day is equal to 20, on the second day 23, and on the third day 26, and so on. We can go on calculating the terms till 23rd day of the month, but there is a shorter way to find the number of bags delivered on any day of the month. We can make use of the formula we have studied previously. Let us look at the general form of the AP. What do you observe? A plus D, A plus 2D, A plus 3D, and so on. What would be the nth term of this general form? If you look closely at the prefix of common difference t, you observe that it is of the form n minus 1. So the nth term of the AP with first term a and the common difference t is given by an is equal to a plus n minus 1 times t. So this is how we arrive upon the formula we had studied. An is called the general term of the AP. If there are m terms in the AP, then m represents the last term, which is sometimes also denoted by L. Coming back to our initial problem, 23rd term would be the number of bags delivered on 23rd day of the month. So A23 is equal to A plus 23 minus 1 times D. Here the first term, that is A, is equal to 20 and the common difference T is equal to 3. Putting them in the equation we get A23 is equal to 20 plus 23 minus 1 times 3, or 20 plus 22 into 3. That gives you 86.